Now let us look at few multiple choice questions. The first question is, the unit impulse is defined as A, delta of t is equal to infinity when t is equal to 0. There is one definition. The second definition is delta of t is equal to infinity, t is equal to 0. And delta of t is equal to 0 when t is not equal to 0. That's the second. Third is delta of t is infinite, t is equal to 0. And integral minus infinity plus infinity delta of t dt is A. Then D, delta of t is equal to infinity, t is equal to 0. Delta of t is 0 when t is equal to not 0. Okay. And the integration of that delta of t d of t minus infinity plus infinity is 1. The answer is the last one, because the last one is the most comprehensive, where we are talking about a complete equation or a complete definition of a delta of t, where we spoke about its value when t is equal to 0 and its value when t is not equal to 0, and also we have given what is the area under the curve. So the answer is D. So if you look at this, okay, this is t and this is equal to 0. So delta of t, how are defining? This is delta of t. It is infinite. So this is infinity when t is equal to 0, and this is 0 when t is not equal to 0. That means this function doesn't exist at other places, exists only at t is equal to 0. This is one. And how do you know the area of this curve? So this exists from minus infinity to plus infinity. If I calculate its area, then this will be equal to 1. So this completely defines the area of the curve. If you look at the question number C, the question number C is almost same, except it is saying that the choice number C says that the area is A. That would have been true if this is A delta of t. So that is not true answer. So the answer is for us is D. So this comprehensively defines everything. So just let us recollect what is answer D. The answer is says delta of t is having an infinite value at t is equal to 0 and is equal to 0 when t is not equal to 0, and the area under the curve is equal to 1. So this comprehensively completely defines the answer. So you have to give its answer by elimination. The first one talks about a single point. It says delta of t is equal to infinity and t is equal to 0. But what about other cases? So it is not complete. So the answer is removed. The second question talks about delta of t is equal to infinity when t is equal to 0 and delta of t is equal to 0 when t is not equal to 0. That's okay, that also defines but doesn't speak of the area under the curve. It only speaks about the magnitude. So that also is incomplete. Then comes a third question. That third question says delta of t is equal to infinity, t is equal to 0, delta of t is 0 when t is equal to not equal to 0. Okay, so these two are fine, and also talks about the area under the curve, but the area under the curve gives it as a capital A, which is some constant A, which again is not true. So finally, if you eliminate all these three because they are not comprehensive or they are not correct, we choose the answer D because of the fact that delta of t exists only at t is equal to 0 and does not exist anywhere, and the area under the curve is always 1. Now let us go to the question number 2. What does the question number 2 says? It says, which of the following is a periodic signal? The first one is x of t is equal to a u of t. Okay, it is a unit step signal. B, x of t is equal to a e to the power of minus j bt. It's a complex exponential signal. X of t is equal to a e to the power of bt. It's a exponential signal. And D, x of t is equal to at. The answer is B, because if you remember a true or false question, we said complex exponential signals are periodic. Unit step is not periodic, or a step signal with a multiplying factor of A is not periodic. Then comes your exponential signal, which is complex. If you look at the third question, of course exponential, so you should be a little careful in putting, but it is not exponential. It's not a complex exponential, it's simply an exponential signal. And D, x of t is equal to at is not a periodic signal. So the answer is B. Now let us see at the question number 3. Which of the following is a non-periodic signal? Earlier we were talking about a periodic signal, and this time we are asking a question on whether the following signals given are non-periodic in nature. A, x of t is equal to a e to the power of minus j under root bt. B, x of t is equal to a e to the power of minus j pi t by b. C, x of t is equal to a e to the power of bt. C, x of t is equal to a e to the power of minus j b pi t. The answer is simple C question. Because if you look at all other three, they're all exponential signals, which are complex exponential signals, whereas the only exponential signal which is not complex is given in choice C. So the answer is C. So you have to be a little careful here. It can be J multiplied by anything, doesn't matter. It's of course a complex exponential signal. So A is a complex exponential signal. If you look at B, is also complex exponential. C is also complex exponential, whereas C happens to be the only signal which is not complex exponential signal, but it's a purely exponential signal. So this becomes a non-periodic signal. So the answer is C. Let's move on to question number 4, which says which of the following statement is false or statements is false. The product of two odd signals is odd. The product of two even signals is even. The product of even and odd is even. The product of even signal and odd signal is odd. Okay. So earlier we have seen one case where we said the product of two odd signals is not odd. So of course the first A is a false statement here. So you have to find out they're also false. So the answer is A and C. So if you look at these, the product of two signals is odd is false. Already we have seen this. Whereas the product of two signals, even signals, which is always even. And the question C, the product of even and odd is even signal is false, because if I take the product of even and odd signal, it becomes an odd signal. And the product of even and odd is, of course, odd signal, because even is false, odd is right. So the answer is two choices which are given here, A and C, are false. So these two choices would have been correct. If I say the product of two odd signals is even, then it would have been true. So A also would be true, that is B. Then B is of course given a true statement. C is talking about the product of even and odd signals being even, whereas D is the correct statement of C, which says the product of even and odd signals is odd. So let us move on. Fifth question, which of the following is a purely even signal? A, the choices are A, x of t is equal to e to the power of at, x of t, B, x of t is equal to cos ohm naught t, C, x of t is equal to e to the power of j ohm naught t, D, x of t is equal to v of t. Which of them is purely even signal? The answer is x of t is equal to cos ohm naught t is the pure even signal. So just look at the C also. C also happens to be an exponential, complex exponential signal, but we are talking about a purely even signal. So we talk about the cos being pure even signal. So the answer is B. Okay, let us look at the sixth question. What does the sixth question say? It says, which of the following is purely odd signal? Okay, the first one is x of t is equal to e to the power of j bt. B, x of t is equal to a to the power of j bt. C, x of t is a sine n ohm naught t. And D, x of t is equal to t square. The answer is C, where x of t is equal to a sine ohm naught t and multiplied by a certain period n ohm naught t is a purely odd signal. So the answer is C. Let's quickly move on to the seventh question. Which of the following is an energy signal? A is x of t is equal to a to the power of j ohm naught t. B, x of t is equal to a sine ohm naught t. C, x of t is equal to b cos ohm naught t. D, x of t is equal to e to the power of minus at ut. The answer is the final question. X of t is equal to e to the power of minus at u of t is an energy signal. So the power of this particular x of t must be 0. That's why this is called as an energy signal. So the answer is D. Now let us look at the question number 8. Question number says, which of the following are true? Periodic signals are power signals. Is it true or false? B, the non-periodic signals are energy signals. True or false? For energy signals, the power is 0. True or false? Energy is finite, that should be made. Okay. So instead of 0, add finite. Okay. A, B and C are true. What does A say? The periodic signals are power signals. The non-periodic signals are energy signals, and for energy signals the power is 0. For power signals the energy is 0 is false. In question number 8, true answers are A, B and C. whereas D is the false answer. These are all true. Now let us move on to the question number 9. Which of the following signal is a causal signal? A. X of t is equal to A. B. X of t is equal to X of t is equal to t. C. X of t is equal to U of t. And D. X of t is equal to e to the power of minus at. The answer is X of t is equal to U of t is the only signal which is causal, that is, it is dependent on time, whereas others are not causal signals. The answer is C. Let's move on to the question number 10. The question number 10 is as follows. Which of the following represents the pulse signal shown in the figure? Okay, you have a pulse signal which is existing from minus 0.5 to plus 0.5. So this is what is given. This is 0.5 and this is minus 0.5 centered around 0. Okay, having a certain amplitude. So which of the following actually represent this signal? A. U of t plus 0.5 minus U of t minus 0.5, that is choice A. Second is U of t minus 0.5 plus U of t plus 0.5. C. U of t minus 0.5 minus U of t plus 0.5. D. U of t plus 0.5 plus U of t minus 0.5. A is the answer. U of t plus 0.5 minus U of t minus 0.5. Okay, that means U of t plus 0.5 means what? It is starting from minus 0.5 and it is going on, whereas the other signal T of U minus 0.5 starting from minus 0.5 and moving towards it. So when I subtract this, what is left is this. Okay, so this is the A is the answer. 11th question. The differential of a unit step signal is ramp signal A, B impulse signal, C exponential signal, D is a parabolic signal. That means if I differentiate a unit step signal, what will I get? Will I get a ramp? Will I get an impulse? Will I get exponential, or will I get a parabolic signal? And the answer is B, I will get a impulse signal. Question number 12. The integral of a unit step signal is infinity A, B 0, C 1, D constant. C is 1. The answer is, if I integrate a unit step signal, I will get the answer as C, that is 1. If x of t is a continuous time signal and delta of t is a unit impulse signal, then integral minus m to plus infinity x of t delta of t minus t delta t is A x of t, B delta of t, C x of t naught, D delta of t naught. The answer is C, because when I integrate minus m to plus infinity delta of t dt, we will get the answer 1. So it is multiplied at t is equal to t naught by x of t. So x of t will exist only at x of t 0. So the answer is x of t 0. So the answer is C. Now let us see question number 14. So what does question number 14 say? If x of t is a continuous time signal and delta of t is a unit impulse signal, then integral x of t delta of t dt will be A x of t, B delta of t, C x of t delta of t, and D delta of t minus tau. So by the method of elimination, we can remove D completely, because there is no tau that is involved in our integration or in the equation. So remove D. And when integrate x of t delta of t, we know that integral of a delta of t signal is 1. So C is also eliminated. Because C is eliminated, B is also eliminated. The answer is A, that is x of t. So any signal integrated with the delta of t signal or impulse signal, you will get the same signal, that is x of t. If I multiply with delta of t minus t naught, earlier question we have seen that it was x of t naught. Okay, when t is equal to t naught. So the answer is A. Let's move on to question number 15. Question number 15 says, which of the following responses of an LTI system does not depend on initial conditions? Which of the following responses of an LTI system does not depend on initial conditions? Natural response A, B free response, C. Forced response, and D. Total response. The answer is forced response. When a forced response is there, it does not depend on initial conditions, whereas natural or free or total response does depend on the initial conditions also, except the forced response. So the answer is C. Now let's look at the question number 16. The homogeneous solution of the differential equation dy of t by dt plus ay of t is equal to x of t, y of 0 is equal to b will be in the form A. C e to the power of at, B. C1 plus C2 e to the power of at, C e to the power of at plus D C1 plus C2. The answer is A. It will be C multiplied by exponential signal e to the power of at. So this is a homogeneous solution of a differential equation. Let us look at the 17th question. The total solution of the differential equation dy of t by dt plus ay of t is x of t. Y of 0 is equal to b will be in the form x of t e to the power of at, that is A, choice A, B, C e to the power of at plus k x of t, choice B, C is equal to k1 plus k2 x of t, choice C, D e to the power of at plus x of t, choice D. The answer is B, that is C e to the power of at plus k x of t. This is a total solution of a differential equation, and the answer is B. Let us see 18th question now. Which of the following is not a static system? A. Y of t is equal to x of t square. B. Y of t is equal to x square of t. C. Y of t is equal to t x of t. D. Y of t is equal to e to the power of xt. The answer is A. Y of t is equal to x of t square is not a static system. Let's look at 19th question now. Which of the following is a time invariant system? A. Y of t is equal to t x of t. B. Y of t is equal to e to the power of x of t. C. Y of t is equal to x of minus t. D. Y of t is equal to x of t square. The time invariant system is B, where y of t is equal to e to the power of x of t is a time invariant system. Question number 20. Which of the following is a linear system? A. Y of t is equal to x of t square. B. Y of t is equal to s square of t. C. Y of t is equal to x of t plus c. D. Y of t is equal to e to the power of x of t. The answer is A, where y of t is equal to x of t square is a linear system. So the answer is A. Let us now look at the question number 21. Which of the following is a causal system? Y of t is equal to x of t square. B. Y of t is equal to x square of t. C. Y of t is equal to x of minus t. And D. Y of t is equal to x of 2t. The answer is B. Causal system is y of t is equal to x square of t. Next question, 22. Which of the following is a non-causal system? A. Y of t is equal to d of x of t by dt. B. Integral t is equal to 0 to t x2 of t x1 of lambda minus t dt. C. Y of t is equal to e to the power of x of t. And D. Y of t is equal to x of t square. The answer is D, which is y of t is equal to x of t square, which is a non-causal system. Now let us look at question number 23. Which of the following statements are true? A. An LTI system is always stable. 2. An LTI system is stable only if the integral of its unit impulse response is finite. 3. In a system, even if the input is bounded, then the output is always bounded. In a system, even if the input is unbounded, the output can be bounded. Okay, these are the statements which are given, and we have to say which one of them is true. That is, A says only second one is true. B, second and fourth are true. C says only third is true, and D, 1 and 4 is only true. So the answer is second and 4 only are true. So what are they? An LTI system is stable only if the integral of impulse response is finite, that is 1. And then if a system, even if the input is unbounded, the output can be bounded. So these are the only two which are correct. So the answer is B. 24th question says, which of the following is a stable system? A. Y of t is equal to t x of t. B. Y of t is equal to t square x of t. C. Y of t is equal to e to the power of t x of t, and y of t is equal to e to the power of minus t x of t. The answer is y of t is equal to e to the power of minus t x of t is the only stable system. So the answer is D. Let's move on to the 25th question. 25th question is as follows. Which of the following impulse responses of LTI system represents an unstable system? H of t is equal to e to the power of at u of t. B. H of t is equal to e to the power of minus at u of t. C. H of t is equal to e to the power of minus t u of t, and D. H of t is equal to e to the power of minus t sin t u of t. The answer is H of t is equal to e to the power of at u of t is the correct answer. Let's move on to the 26th question. 26th question is, which of the following impulse responses of LTI system represent a stable system? A. H of t is equal to e to the power of t cos t u of t. B. H of t e to the power of t sin t u of t. C. H of t e to the power of minus t cos t u of t, and D. H of t t sin t u of t. The answer is C. H of t is equal to e to the power of minus t cos u of t. 27th question. Which of the following represents the convolution of two causal signals x1 of t and x2 of t? A. Integral lambda is equal to 0 to t x1 of lambda x2 of t minus lambda d lambda. 2. A by small a multiplied by 1 minus e to the power of minus a t u of t. 3. Integral t is equal to 0 to t x1 of t x2 of lambda minus t dt. 4. T is equal to 0 to t x2 of t x1 lambda of t dt. The answer is D, where all of them are correct answers. So these are the various representations of convolution of two signals, out of which some are famous, some others are little not that famous, but all of them are in fact true. So answer is D. Moving on, next question, 28th question. If H1 of t and H2 of t are impulse responses of two stable LTI systems in cascade, then overall impulse response of the cascade system is A. H1 of t convolved with H2 of t. B. H1 of t multiplied with H2 of t. C. H1 of t plus H2 of t, and D. H1 of t minus H2 of t. The answer is A. H1 of t convolved with H2 of t. Let's move on to the last question of this session. If the impulse response of an LTI causal system is in the form e to the power of minus at, then the response for step input of value A will be of the form A e to the power of minus at u of t, B a e to the power of minus at u of t, C a by a 1 minus e to the power of minus at u of t, D a minus e to the power of minus at u of t, and the answer is C, where C is equal to a by small a 1 minus e to the power of minus at u of t.